Hello and welcome to this video on how to teach the electrolysis of aluminium at GCSE level. Right, this is one area where people sometimes struggle on, and I hope that this video outlines a number of different bits and bobs that you can do to try and make this a bit more engaging for students. The way that I always start the lesson is to do an activity that goes and reminds students what electrolysis is. Right, usually in the previous lesson I've gone through and talked about the electrolysis of lead bromide, so this is an ample opportunity to go through and give them a little bit of exam practice looking at long answer questions. So I start off by reminding them how to use a long answer question, so a 6-mark question in this case. I give them 4 answers and I give them a mark scheme. You go through, I remind them that they primarily need to be looking at the science points. Then they go through, they annotate each of those answers, marking where the marks are coming from, and then they can go back and look at the SPAG. This is probably one of the areas in science where we actually can use SPAG effectively, so it's worth using, even if in the new spec there's no actual marks available for it. After they've gone and marked it, they can go through and give it a grade. After I've carried out this short activity and ran through the objectives, we move into looking at a big model to show how the electrolysis of aluminium works. Right, the next video clip will outline how to use this model in detail. The key to setting up a successful demo about the electrolysis of aluminium is to be prepared. Make sure that you've got all of your bits cut out well in advance, including your aluminium atoms, your oxygen atoms, and some electrons. The way that it works is you move through it using stages. The easiest way to do it is to make sure that all of the stages are cut out and sat in a pile ready to use. The first stage talks about your basic part of electrolysis. So you need to refer back to electrolysis is the breaking up of ionic compounds using electricity. Keep referring back to exam questions and use this opportunity to keep asking students different questions around this. Right, what I like to do next is to go and show them what the aluminium oxide actually looks like. So it's made of 3 oxygen atoms and 2 aluminium atoms. Right? Because they're charged particles or charged atoms, you can go and use this opportunity to question students and help reinforce anything that you've previously done on ionic bonding in terms of balancing the charges. After you've done this, you can move on to stage 2. So stage 2 is talking just about the bauxite, so the aluminium ore. It's always worth referring back to aluminium ores. Ask students questions on what an ore is. Right? Remember, in exams they'll quite often be asked this, and all they need to say is an ore is a mixture of the metal compound we want with other stuff. Right? So we need to talk about the fact that the bauxite ore is purified, and that purified bauxite ore gives us our aluminium oxide. You can then go in stage 3. You can start to move some of your atoms into the little pot that you've made with this. Remember, when you're making the pot, the negative part needs to go at the bottom, so it's almost opposite where your 2 positive electrodes that you've cut out are, so students can make that distinction. It's important to go and ask and point out that you're adding in cryolite. You talk, or you can inform students that the cryolite is there to lower temperatures. Right, this is another good opportunity to question students and remind them about what catalysts are, what catalysts do, and get them to think about the fact that the cryolite is going to lower the melting point, so therefore less energy is needed, so it will save money. The next stage, so stage 4, we go and we talk about our electrodes. So positive electrode, you'll need to go and move the oxygen. So because we've got these cut out, we can move them around. So the oxygen can go and move to it. Right. At this point, this is the first time when we can use some of our electrons, and you can show that each of these oxygen atoms, because they've got a negative charge of 2, they lose 2 electrons into this positive electrode, and you can show them that the oxygen goes and bubbles off. Right, so bubbles off. Right, take this opportunity to remind them that the electrode is made out of graphite and get them to think, right, question your more able students about what the problem is going to be with creating really hot oxygen atoms at a positive electrode that's made out of graphite, which is carbon. Right, hopefully some of them should come up and say, well, when it reacts together, it will form carbon dioxide. Next, we can do the same, just with the negative electrode. So we can show that our positive aluminium moves towards the negative electrode. Right, point out that the negative electrode is negative because it's got extra electrons in it. And you can show that the aluminium is gaining 3 extra electrons each, which will give it no overall charge. Right, at this point, it might be worth thinking about getting them to think about half equations briefly. So you can go, put them there, you can show that the oxygen is going to lose 2 electrons. Right, so if you had a little pen, you could put a minus sign there, so that would lose 2 electrons. Now aluminium is going to gain 3 electrons. If you've already got these set up like that, then it will help when you come to talk about half equations shortly. Right? So we've talked about that. Point out, keep reinforcing that oppositely charged ions will be attracted to the oppositely charged electrodes. So the positively charged aluminium is always going to move towards negative, and negatively charged oxygen is always going to move towards positive. Right, and finish off simply talking about the half equations. You may want to go and write around it using a pen, but that is basically how we are going to use this model to go and explain how the electrolysis of aluminium takes place. So, after students have watched you go through and carry out a modelling activity, have been asked specific questions on it, they can then go and produce their own annotated diagrams, or if you wish, you can get them to take photos of it, which can be really useful because they're not going to lose it because it's on the phone, and they can refer back to it. After this point, I like to carry out an activity called micro-teaching with them. This is where students, either individually or in pairs, are going to produce a presentation on the electrolysis of aluminium, in this case, based on what they have just done. They will then present it to a number of different groups, which is shown in the short clip next. The first stage in carrying out a micro-teaching activity is to give the students the opportunity, in pairs preferably, but it can be done individually, to go and prepare a short presentation on a particular topic. Once they have prepared their own presentation, and in some cases you'll give them different sections to look at, you need to go and arrange the tables along the centre of the room. You might need to do more than one row and sit students at either side so they face into each other. Once one pair is facing the other pair, they give their presentation to the pair opposite them and vice versa. Second stage is that all of the pairs move around the table clockwise. So now all of the pairs are facing a different pair. They then go and give their presentation to this different pair and vice versa. By doing this, they're starting to pick up on the key points that they need to make, so they can go through and be noting down these key points if they've missed any, and it's starting to help embed the key ideas into their heads as they're needing to explain it to another group. Third stage, continue rotating them round clockwise, so each pair continues to face a different pair. They carry on giving the presentations to the different pair and so on. Periodically, make sure that you're stopping the groups, asking directed questions to students to ensure that they're picking up on the key points, and so that you can help get around any misconceptions that they may be picking up. Right, this is a nice, easy, quick activity that you can use that really engages the students and really gets them thinking about the content. So, after students have finished their micro-teaching activity, you can then move on to the plenary just to ensure that students are consolidating what they've learned. The way that I like to do this, and it's a good way to get them thinking about these 6-mark questions again, is to give them a 6-mark question on the electrolysis of aluminium. If you wanted to give them the mark scheme at the same time, that's fine. They can fold it over so they're not looking at the mark scheme, or you can cut the mark scheme off and give the mark schemes out after. Give the students a maximum of 5 minutes to go through and answer the question using what they've done in their micro-teaching activity and the diagrams that they'll have hopefully made during the modelling activity. Get them to go and answer the question in 5 minutes, then stop them and give them a minute to go through and check carefully. After students have gone through and checked, you can get them to swap over and, using green pens for instance, mark each other's work and give feedback on how they can improve, and on the mark scheme direct them towards anything in particular that they've missed from their answer. Right, this is a really good activity that starts to build up students' confidence when answering 6-mark questions, and it really consolidates what they've learned during the lesson. You can then use hands up or any other method to go and assess how students have done really quickly. Hopefully this video has given you some ideas how to teach this particular concept. If you've liked this video, please subscribe, like the video. There's links below to follow me on Facebook, Twitter, and there's a link below to my shop on test where you can go and get a full copy of this lesson. Please feel free to leave any comments or questions below and I will get back to you as quickly as possible. Thanks for watching and happy teaching.